So it's been a minute since I've seen you guys. So let's kind of,
Do you need my points packet?
yeah.
Because
So
I
if you-
didn't see one for a
Sure, if you have your points packet and you haven't turned that in yet, go ahead and let's do that. I'll just put the folder up here and just stick it in there. If you've got that and you want to unload it, please do that at your leisure. Before you leave today, it would be spectacular, but like, I get if you're like, ooh, I don't know where that is.
Yeah, I don't know where that is. I didn't come home.
Yeah, you'll find it when I'm bringing it soon, right?
I can almost write it.
Yep, pencil your bro.
In the cup of my desk.
Thank you.
Yep. So, let's just kind of catch up, right? So I think we've closed out everything that we needed to do for for test 2, right? Ideally that should have happened by now, but with all the me missings and you missings, and it hasn't, which is fine. My plan for today is I'm gonna do section 3. That will not be part of test 2. We'll talk about the test 2 format to give you an idea of like, what's on there, what kind of questions you're gonna ask, how's the format gonna look like. I will do all of that today also. You can fire away questions at will, or me. There's no will in class, so. I think the tentative test date then for you guys, I think Monday I wasn't allowed to give the test for first hour. So it means that it's going to be Wednesday, Thursday. We'll do the next section 3, 4, then on Monday or Tuesday. And we'll just do everybody cool with the plan?
Yes.
Okay, any more questions on stuff? I won't do any homework quizzes until after the test day. So you don't have to worry about a 3-3 or 3-4 homework quiz. Although I would say maybe
Sorry.
Yeah.
It's been a little weird.
So what I would say is that, I won't have any homework quiz before the test day, but after the test, the next homework quiz after could include elements from sections 3-2, 3-3, 3-4, some of these sections that we haven't done a homework quiz on. The one after the test, I might have some of these ideas all mixed in there together. Okay, fair enough? Fair enough, right? All right. Do you guys have questions on things from whether it's my EP multiple choice questions or FRQs or the worksheet that I gave you guys or the 3-1, 3-2 homeworks or anything kind of in between? I'm just gonna start with like open-ended, like is there something that you've been looking at that you're like, forget this thing, whatever this was, I don't have any clue what to do with this. Probably, but if you can find any of that right now, we can do that. If not, we can hit it next week when you come back. Yeah, Lucia.
Can you give number 23 and 3.2?
3.2, number 23. I should give it that.
I have a really quick question. Can I ask you about this?
Not this second,
Okay.
but we could do all that sound. This thing. Try that again. So this is 3-2, right? You said 23?
Yeah.
Okay. Does that look right, Lucia?
Yeah.
Okay. So when I look at this, this is a fairly common AP presentation as well, where you're given constants A, B, C.
Okay.
Those are just constants. You treat them the same way you would a number, but you can't type it in your calculator now to have an answer right now.
Yeah.
Right? So it forces you to be able to do this algebraically. So when I look at this, there's no way to get this to be anything other than a quotient problem. Because I have, in the denominator, my function of x contains more than one term that can't be combined. right? Because one of them is just a constant, the other is an exponential. I can't add those together. Does everybody see that? If I had a monomial in my denominator, I could turn that into just like something I could power rule or whatever and get away with it. Maybe. But the way it's currently written, I'm stuck quotient ruling this thing. Everybody ready? Okay. What is the quotient rule? Let's just say the numerator is u and the denominator is v. How do I write the quotient rule?
It's u prime and
U prime
v.
times U. U prime.
Is that right?
Yeah.
Okay. Stone cold, you must know that formula for test 2. Okay? And not just for test 2, but for test 3 and 4 and 5 and all the way through the entire semester. And if you're an engineering student, for the next several years of your life, you're going to commit this to memory. You'll use it all the time.
So on the test, will you ask us specifically to use the quotient rule in a question?
Nope.
Or will we-
You'll have to recognize that you need to do it, which is the rough part, right? So for this class, much of this comes down to the how to do it being not that bad, what to do and when to do it being really kind of the sticky point. Everybody's okay? All right. So probably in a situation like this, this is complicated enough that it's probably easier to just look at the derivative of u and v separately and then put it all together in the formula afterward. What's the derivative of a? Oh. 0. Why is it 0? Because it's a constant. Yeah. We love constants. We love them. The derivative of v is?
E to the x. Or 0.
Neither of those,
Okay.
unfortunately. You're a little right on both of them, but
It's E, you know.
is it 1? Zero plus c times e to the x. You guys see it? The derivative of b is just the derivative of b is a constant. That's the 0. C times e to the x. I pull the constant out front, so I have c times the derivative of e to the x, and the derivative of e to the x is just e to the x. So I have just c times e to the x. Is everybody cool? Okay. So if we fill this in, I have 0 times c times e to the x minus, oops, sorry, that's b plus c times e to the x minus c times e to the x times a all over b plus c times e to the x squared. Lucia, you good with where I put everything?
Mm-hmm.
Okay. Anything times 0 is?
0.
That stuff all gone. So this should just be negative ac e to the x over b plus c e to the x squared. And I wouldn't do anything past that.
Yeah. So you wouldn't like 4 on the bottom?
No need to.
Okay.
You okay? Let's do 24. I really like 24. Almost like there'd be a question real similar to this that could possibly appear on a test that might come in the near future. I don't know, I'm just saying. This reeks of something Mr. Gulick would ask about, though. All right. How do I do the derivative of this thing in 24? Is there any way to weasel out of not having to do a quotient rule? It's written as a division of two things. Any way for me to weasel my way out of that?
It's by the reciprocal. To make it not visible.
If that's gonna help any. I mean, you can do it. It's gonna make it messier, I think, though. In fact, it'll give you a function that you can't differentiate yet, which is awesome, right? The answer is no, right? You're stuck quotient ruling this for really the same reason as before. If I look at the denominator, I have two terms that can't be combined. One is linear, the other is exponential. If I can't get that into one piece, there's no way to not have this be a quotient rule problem. Everybody's good? Okay. So we'll do the same thing. The derivative of the top is nope. What's the derivative of 1 minus x e to the x?
Negative x e to the x.
Nope.
Oh my gosh. Negative x squared e.
Nope.
Negative e.
Nope.
Okay, I'm gonna stop trying.
No, I love that you're trying.
No,
Keep
I'm
trying. No, this is good. It is okay. Like, it is okay to keep spitting out the wrong answer. It's encouraged. Please participate. Don't give up. Okay? Don't give up. It's not 0.
Negative x squared.
Nope.
Negative x e x.
Nope. It's negative x minus x e to the x.
What?
I'm sorry, it's negative e to the x minus x e to the x. How did I get that?
Yeah.
Product rule. Do you see that I have x times e to the x there? That's a function times another function, correct? To differentiate the product of two functions, we must do the product rule. Let's write it out so you can see it easier. Right? So I take the derivative of u, which is just the derivative of 1 minus x e to the x. I can distribute that derivative operation across the binomial there. The derivative of 1 is just 0. So I have 0 minus the derivative of x e to the x. That's the product of two functions, x and e to the x. The product rule says that's the first times the derivative of the second, plus the second times the derivative of the first. So I'm going to get rid of the 0. I just have minus x e to the x minus e to the x times 1, or negative e to the x minus x e to the x.
So when the constant is behind the e to the x, it's 1, but when it's in front of e to the x, it stays as an x. Like, I'm just trying to understand why you made x 1 in the second part, but not in the first part.
Yeah. Okay. So that's the formula for the product property.
Mm-hmm.
So it's the first function times the derivative of the second,
Oh. So
plus the second function times the derivative of the first.
So it wasn't asking for the derivative of the first times and the second
Does that make sense?
times. Mm-hmm.
Again, do you have to memorize that? Oh, yes. And not just for test 2, but for tests 3, 4, 5, 6, all the way through. And if you're an engineering student, for the next several years of your life. Okay? My suggestion to you is these initial derivative shortcuts, these derivative properties, you need to memorize them so well that your children will know them. Okay? Like, it will pay incredible dividends to have these things on instant recall where you don't have to think about it. where you see it as soon as it's there. You know exactly where that came from. You're like, oh yeah, that's just they did the product probably there. Oh yeah, that's the quotient probably they did there. Even if you don't see it initially to do the problem, when you look at the answer, it's like, oh, I see what they did. Okay? Gotta have it. Got to. Non-negotiable. So far, so good? And then we need v prime. So the derivative of x plus e to the x. Do we need anything special to do that? No, right? What's the derivative of x plus e to the x? Close. 1 plus e to the x. Don't be discouraged. I know, it feels like I'm not doing anything right today. You are doing just fine. We want to get all, like, participate. Like, see what you don't know and what you do know. Like, you're getting so much extra feedback by doing that. It's really going to be helpful. Like, don't sit on it, your understanding or not understanding. Like, let it be out there, let it be public. Let you get firsthand, like, ooh, I don't know this as well as I thought I did, or I do know this as well as I thought I did, but like, get some feedback out of it. Like, this needs to be not a just one-way street where Mr. Kool-Aid does this flawlessly in front of you and you don't get to, participate. You should want to participate. Like, shout out answers if you think you got them. Whatever your instinct says, so you get to know, like, okay, I do know this as well as I thought I did, I'm doing great, or, ooh, boy, I gotta tighten this up a little bit, I need to go back and spend a little bit more time on this. Or I'm seeing like, oh, I keep making the same silly mistake each time, I need to be mindful of that. Like, get some feedback, for God's sakes, it'll help so much. Okay, so don't stop, okay? Everybody's okay? Never mad at wrong answers, okay? Okay, so now let's start filling in, right? So we have u prime times v minus v prime times u all over v squared. Is everybody okay? If this is a free response question on a test, the calculus is finished now, right? We did all the derivatives. You could stop at this point. If this is a multiple choice question, that will not be one of the options. We'll have a more simplified option on a multiple choice question. So we'll continue, but if this was free response, you could stop here. Once the derivatives are done, the calculus is finished, you may stop. That's the policy on any free response question for me, as well on the AP exam. There's no bonus points for cleaning things up and making it look pretty. All you're doing is burning time that you could be spent working on something that's really difficult rather than plugging through some algebra to get a more satisfying looking answer. Even if it's a numeric, like if you plugged in the numbers and don't do the arithmetic, you can be done, full marks. Move on. Okay? So again, same thing would go for me, especially on the no calculator portions. Like, plug in a number and move on. There's no sense in like continuing to grind away at stuff that like you did it. The calculus is done. You have a number. Just let it be ugly. It's okay. It's okay to have it be like 3 squared minus 7 times 4 all over 6 plus 7 times 8. Like, I don't care what the fraction is. That's a number. Move on. You're good. Okay. Let's FOIL this out though, because we said we were going to simplify it a little bit in the event that this was a multiple choice question. So I have negative x e to the x times x, so that's negative x squared e to the x. Negative x times, or negative x e to the x times e to the x is negative x e to the 2x. Negative e to the x times x is just x, or negative x e to the x. And negative e to the x times e to the x is negative e to the 2x. And then I have 1 times 1 is 1, and then make it negative. 1 times negative e to the x, or I'm sorry, 1 times negative x e to the x, and then make it negative is 1 plus. And then e to the x times 1 is e to the x, but make it negative. And then I have e to the x times negative x e to the x, and then make it negative is plus x e to the 2x. Whoa, stay. And then, oops. Now.
This is where you can like cross things out.
Yeah, so now that everything is out of parentheses, it's all just like adding and subtracting. We can certainly cancel some things. So, bye-bye. Bye-bye. And I think after that, we are as good as we can do, right?
Mm-hmm.
Yeah. I guess that is fine. I think that's just, I don't think I can factor that anymore. Looking at that. Is there any grouping I could do there? It doesn't look like it. I don't think so. I think that's as good as it gets. Of course, yeah, go ahead. Okay. We feel okay on this? I want to point out to you, as talking through this, nobody saw the product rule nested inside of the quotient rule. I promise you on test 2 you will. Okay? So, do some more practice. If you look at this, this guy that I gave you, the derivatives worksheet. So I have like stuff that can be done without quotient or product rules that you can just do algebra to get around having to do that. Stuff that you can't. Included in these things are going to be problems that have product rules inside of quotient rules. Now, I'm going to warn you, some of these are like quite difficult, unnecessarily difficult and tedious, beyond the scope of what I would give you on a test. But like if you can grind through this and make sense of it, feel good about it, you'll be in fantastic shape. And then I have some problems that can be done either way. Some of them will be, you can get around having to do product and quotient rules, and some of them you will not be able to. So I kind of mix them together, and you may see, again, product rules inside of quotient rules on some of these. Lucia.
Can you go over an example where we would have to use a product rule and not like in a quotient rule? Like what we should look to see it.
So I look at this.
Okay.
So I have 10x squared e to the x. Can I combine x squared and e to the x? No. Those are two separate functions. Must use a product rule. Okay? Or compare that to x squared times square root x cubed times cube root x to the 5th. Those I can write as x squared times x to the 3/2 times x to the 5/3, and then multiply them together by adding the exponents into a single x. If I do that, no product rule is necessary afterward. Do you see what the difference?
Yeah.
So if I can combine it down and do the multiplication, get it into one single variable, no product rule necessary. If I cannot, must use a product rule. Does that feel better? Sam?
Would quotient rule be like if I have like x squared over e to the x?
Correct. Yes, 100%. That's an impossible to get past doing a quotient rule if you had x squared over e to the x. So you're essentially what you're looking for here is if you have e to the x's and polynomial in the same thing, right? If they're being added or multiplied or divided, you're stuck having to do a quotient or product rule on something like that. If you have both an e to the x and a polynomial that are being multiplied or divided, there's no way of getting around a product or quotient, because those two types of functions are uncombinable. Everybody feel okay? Does that help kind of getting into the frame of mind of like what to expect come test time, I hope? Now that last problem 24, was a little bit ugly. I probably won't give you something quite as ugly as that on the test, but far from it. You know, like that's pretty representative. So far, so good. Should we talk about go on and talk about 3.3 now, and we'll circle back and do some more test stuff at the end? Sound good? Okay. Nobody get too down on themselves, I hope. Everything is fine. All right. Who missed trigonometry? Because that's what we're about to see here, is a whole bunch of trig. So we're going to be looking at derivatives of trigonometric functions. So to some extent, we're still going to want to be able to look at what we have to differentiate and see if we can make the problem easier via algebra. If you have trig things, what is the algebraic tool you're going to be using to try to make that thing simpler? Your trig identities. So like tangent equals sine over cosine, or sine squared plus cosine squared is equal to 1, or fill in the blank, right? You guys, I would say that your reciprocal identities like cosecant is 1 over sine, you know, your quotient identities like tangent is sine over cosine, your Pythagorean identities like sine squared plus cosine squared is equal to 1. That's as far as you really probably need to have still memorized. Don't worry about the double angle and the sum and difference angle identities. While those could come up in the homework, I would not put them on the test. I haven't seen the AP really put them on a test. That you need to be able to use the identity to get around. So, just putting that out there for you. All right, so we had a homework assignment some ways back, I think in like 2.8 or 3.1, where we looked at the graph of sine x and tried to sketch the graph of the derivative and observe that it was cosine. Do you guys remember doing that homework problem? We're going to prove that here. Sound good? Okay. If I want to prove a derivative, the tool I need to use is the limit definition of the derivative. Yikes, Mr. Kulik. Okay, I need to change the thickness here. This is too thick.
Mr. Cool,
Yes.
I'm struggling a lot on this one question right here.
Okay, well we can talk after class. Right now we're doing this.
Okay, sorry.
I'm happy to help, but
Okay.
like this is not a great time.
Okay,
You know what I mean? That's okay. No big deal. So this is just the limit definition of a derivative, right? If I try doing a direct substitution here, we get 0 over 0. You guys see it? Sine x minus sine x over 0. So we have to clear that indeterminate hurdle somehow. How are we going to do that? You'll need a trig identity to do it. Which piece was the piece that we're going to apply the trig identity to? What's that? The part that you're plugging in. Not sure. It's going to be the sine of x plus h. What trig identity are we going to use here? Angle sum.
How do you?
How do I know that?
Yeah, like what got you? Like, no.
How would I know to do that?
Yeah.
Well, because there's nothing else that I can do to get anywhere in the problem. So if I look at this, there's no other writing sine x. I could write it as like 1 over cosecant x. Well, what does that get me? Doesn't give me nothing, right? Like it's just like, okay, what I need to do is be able to get that h, that x plus h, and break that apart into like an x and an h separately, so I have a chance of doing some direct substitution and making something work out here. But as long as that x plus h is stuck inside that sign, I can't get past this indeterminate point. So I'm just hoping that if I can separate the x and the h by using that angle sum formula, that I can get to a different spot. Okay? Now I have to always Google these because I never remember either. I think it's going to be like sine alpha plus cosine beta times sine beta, or plus sine beta cosine alpha is what I think is the angle formula, but quite frankly, I don't remember. Yeah, that was it. So I'm looking at this guy right here. All right. Oops. And I need you. Everybody okay with what I did there? Just applied the double angle identity. So that part in green became that. Now, what that did for me is it got the x plus h out of there. Now I have sine x's and cosine x's and sine h's and cosine h's. Everybody see it? Let's try direct substitution again and see how that works. Cosine of 0 is 1.
Okay.
So the first term is just sine x. Sine of 0 is 0. So the second term becomes 0. And then I have minus sine x. That's going to be another 0 over 0. So I haven't done it yet. I haven't cleared that indeterminate hurdle. So we need to keep going. What I'm going to do is I see that, well, this guy, that part has a sine x in it. Oops. And that part has a sine x in it. You guys see that? I'm going to group those together and factor the sine x out. And I am going to, both of these two things need to be over h. I'm going to stick the h on this guy and on that guy. So this is the yellow parts, right? And then this is the left over. Everybody okay with how I rearrange this thing? Now, this still isn't going to clear that indeterminate hurdle because I haven't really done anything other than rearrange. So I'm going to do a limit property now and distribute that limit through to some pieces. So notice in this first piece, this part has no h in it, which is what we're doing, taking the limit of, right? So, respective to this limit, sine x is a constant. So that just can pull out front. Oops. So I can do that. So I took the parts that had just the x's, pulled those out front of the limit, because the limit is only with respect to h. All the stuff with the h's in it is still inside the limits. And I see something really exciting. What's that limit? Huh?
Undefined.
Nope.
It has a 0 on the bottom, so it would be.
Zero.
Oh, you guys have all done this. You've done this limit before.
Is that SM? Or is that, oh, that's sine.
That's sine of h over h.
It's undefined. It can't be. Isn't it one of the 7 ones that
I don't
have
even know what
like?
sine of h means. Zero.
No.
It's zero.
What is sine of?
One.
1, correct. How'd you get it?
Who said that? I guess.
You guys. Who has their points back packet?
It's right
That's
there.
what I thought.
Look at question number 1. What limit were we trying to find there?
Sine of x.
Sine x over x, right?
Yeah.
What are we doing? Sine h over h. What's the limit going to on question 1? Is it x goes to?
Is x going? It's from -1 to 1.
So as x goes to 0 though, right?
Yeah, it's
The
x goes
limit?
to 0. It says
So-
here that sine of x is equal to 0.
I know, it's wrong though.
Oh,
You found it was 1 on
you
there,
got
I
it
think.
wrong. I got it wrong too.
That's okay.
Okay.
You should come talk to me. It's not a big deal. So it should be 1. This is 1. We've already done that.
It would be undefined though, because its limit to 0 is 0 on the bottom.
You squeezed the limit.
Oh.
Oh.
So we did it. We did it in the points back assignment.
Yeah, I have mine. I didn't turn it in yet because I haven't seen it, but also because I had a question on
That's
that
okay.
same one. So.
That's okay.
No, I did that.
All right. Everybody's okay here? So far? This though, if you do a direct substitution, you end up with 0 for 0 again. So we have to do something like this. But we're getting closer, right? Because this is just cosine. That's what we want. What do you suppose this limit's going to have to turn out? Well, the derivative of sine is cosine. That's what we're trying to prove. Here is our cosine. What is this part going to have to be to make the derivative correct? It's got to be 0, right? Sine times 0 is 0. 0 plus cosine is just cosine, right? So we know that has to turn out to be 0, right? Do you want to see the details, or do you just want to trace me on
I just believe you.
it? Okay, sounds good.
I thought I was correct on the point back.
So there you go. Would I ever ask you to do one of these proofs on a test? No. I'll show you later an example of something that I would expect you to be able to do that doesn't involve having to use the definition of a limit, which I think is totally doable for you. Lucy is like, I don't know about that. Okay. So, pointing out to, these were 2 of the steps we used, right? And proving that the derivative of sine is cosine. Okay. So we have this. Do you have to memorize that?
Yeah.
Yup. All right. Let's differentiate x squared times sine x. What do you notice there?
2x.
It's a
Two functions.
2x
multiplication.
times
Two
cosine.
forms.
Yeah, so what do we have to use?
Product.
Product property. Everybody's okay? Product propertying it. Haven't done the derivatives yet, but we set up the product property.
Pretty easy there.
Derivative of sine is
Cosine.
cosine. The derivative of x squared is
2x.
2x. And then you just write this as probably 2x sine x. And we're done. Everybody feel okay
Will we
here?
have something like that on the test?
Definitely. Except we don't have any sines yet.
Okay.
So we wouldn't have this problem because the trig rules are not on test 2. But on test 3, for sure.
Oh, that's like a month away. Okay.
Yeah, that's always November problem.
Got it.
We're in October
That's
problem
fine.
land.
That's fine.
Sarah, of course.
Oh, so you can just stop there.
Yep, and we're done.
Yeah.
All right, the derivative of cosine is
Sine.
not close.
Oh my god.
Negative
It's
sign.
literally right there.
It's not better. It's okay. Look, you used your instinct.
I did.
That's okay.
Because the derivative of sine is cosine. So you would think it the other way around as well. But it's not.
We're gonna skip the proof of this because it's basically the repeat of the proof for sine, and it stinks. We're not gonna do it. Everybody's okay? The derivative of tangent is secant squared. This we will do. This is something that I think is realistic for you guys to be able to do. Let's show you how. Yeah? Now, we don't know, we know the derivative of tangent is secant squared, but if we didn't know that, the only two derivative rules we have for trigs are the derivative of sine is cosine, and the derivative of cosine is negative sine. Is there a way to rewrite tangent? So, go ahead. Go, Mark.
Sine over cosine.
Yeah. So if we do the derivative then of sine over cosine, what are we going to have to use to do that?
Negative cosine over sine.
Oh,
Oh
no.
wait, sine over cosine over negative sine.
Noah? It's the quotient rule! Yes, quotient rule. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Quotient rule, right? You have the division of two functions that you can't combine into one without taking back the tangent, and we're trying to prove the rule. What are we going to do with that? All right, what's the derivative of sine?
Cosine.
Cosine.
Derivative of cosine is negative sine.
Stop, you're cheating.
And the derivative of cosine is negative sine.
Yes.
Good.
Yes.
So here we have cosine times cosine. What's that?
Cosine squared.
Okay. And here we have negative sine times negative sine.
Sine squared.
And the denominator is still cosine squared. What's cosine squared plus sine squared?
I don't know.
1. Right? That's one of the Pythagorean identities. And 1 over cosine squared is secant squared. And what were we supposed to end up with?
Secant squared. Hey, what was that little squiggly box thing?
That's what you do at the end of a proof to show your box.
Oh, I didn't know that.
Yeah.
So you
So,
just do a little box with a little squiggle?
Usually it's like colored in, but like I'm always too lazy to like color it all the way in. You know? Like if you're reading this is going to be take me back, Joe. If you read a magazine and the article goes in like from like one page to another, and sometimes there's like a break, and so there's part of another article in there. At the final end of the article, if you notice instead of a period, they have the same like black filled in box to show that like, yeah, that's the full end of the article. Same idea. Anyway, this type of proof where you're just using your rules for derivatives, your shortcuts, to piece it together, I think is totally fair. Do you guys agree? So that would be something like a test 2 or test 3 kind of problem that I think is totally fair. You know, to prove that, you know, this is equal to this, and all you're doing is using your derivative rules along the way. Totally realistic. All right. We're not going to prove the rest of these, but we have these other 3 derivative shortcuts. So the derivative of cosecant is negative cosecant x times cotangent x. The derivative of secant is secant x times tangent x. And the derivative of cotangent is negative cosecant squared.
Do you have to memorize that one?
Yes.
Oh.
So these are ones, again, you must memorize. I know. It is what it is.
What can you do?
What can you do? At some point, that's just what it is, right? Alright, how are we all feeling so far? Okay, science, great. It's not very reassuring on my end, but I'm gonna chalk it up to you haven't seen me in like a week.
Yeah,
or
that's
more. It's been a minute since you've had any Dr. Gula contact time. So.
Yeah.
What's that? Akshu?
No, you just said Dr. Koo, or you said Koo.
Oh.
I like it.
Okay, go ahead.
Dr. Koo.
All right. So again, we're accumulating a list of memorization, right? Guess what? There's a lot more coming. Because we haven't done yet inverse trigs, logarithms, other exponentials other than e. So there's still quite a bit more derivative shortcuts coming. You're about halfway through right now, I would say. Yes.
Can I make like a cheat sheet? Write it all down on the sheet.
I actually have a Quizlet with all the derivative shortcuts on it that I'll share with you once we've completed them all.
Awesome.
So
Thank you.
I would encourage you to start now
Okay.
and make your own cheat sheet. But once we've got them all done, I have a Quizlet made with all of them on there for you to work on.
Cool. Thank you.
Yeah, no problem. Let's do this guy here. So it says differentiate secant x over 1 plus tangent x. For what values of x does the graph of f have a horizontal tangent? So really there's 2 parts, right? One is we have to find the derivative. And the second, it says for what values of x does the graph have a horizontal tangent? Well, how are we going to use the derivative to answer that second part? Mark?
0 slope.
So horizontal tangent means 0 slope. So we're going to set the derivative equal to 0 and solve for x. Everybody's good with that plan? But there's 2 steps. Got to find that derivative first. When I look at this, I see the derivative secant plus the derivative tangent. The derivative secant stinks. The derivative tangent stinks. I don't like what I'm looking at right here. If it's me, I probably am going to try to do some algebra to sneak my way to a little bit more convenient looking situation. So when I look at this, I would say, okay, secant, that's 1 over cosine. 1 plus tangent, well, that's tangent is sine over cosine. If I look at the small fractions inside the big fraction, what do you notice they both have? Cosine where? In the denominator. So I'm going to do like a clear fractions thing. And I'll multiply like the top and bottom of this by cosine over 1. Everybody's okay with this? Just like when we've cleared fractions in the past. So the numerator is 1. Yes, I love that. Because what's the derivative of 1?
0.
0. I love when that happens, right? And in the bottom, I'm going to have cosine x plus sine x. Everybody feel good there? I'd much rather differentiate this. That looks easier to me. What do you guys say? Yeah, I think so too. All right. So our derivative, to differentiate that, what are we going to have to use? Very good, Frankie. Quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Everybody happy with what we did so far? What's the derivative of 1?
0. So that's all 0.
Bye-bye.
Wow.
Love that. Right? Unit fractions. Yes. And derivative of cosine.
Negative sign.
Okay, and then we have the negative out front, so that's going to make it positive.
No, I'm never forgetting that.
And the derivative of sine is
Cosine.
cosine, and the negative comes through, so the negative cosine. That's right. You got it now. Okay, so that's good enough for me, right? That'll good enough for a derivative. So now we would set this equal to 0 and solve for x. How do we solve that equal to 0? No, man.
No.
I mean, not a terrible idea, but no. We don't need to do that. Let's not. The thing on the left is a fraction, right?
Yeah.
When is a fraction equal to 0? When the numerator is 0 and the denominator is not 0. Everybody good?
Yep.
Okay. So we'll just say and I'm not going to worry about the squared in the denominator because the only way for something squared to be 0 is if it's 0. So I'm just going to take the inside part, set it not equal to 0. All right, how do I solve sine x minus cosine x equal to 0? Oh no, can't do that.
You add cosine to the other side.
Yes! Well, let's actually subtract sine from to the other side. But like the right idea for sure. So we'd have negative cosine, not cosine. Cosine x equals negative sine x. Then what do you want to do? Divide by? Let's divide by negative cosine. Is that okay with everybody? So you're going to get 1 equals sine x over cosine x, or 1 is equal to tan x. Right?
When you divide by the same, you divide one number by the same number, it's 1. Like 2 divided by 2 is 1.
So if I divide both sides by negative sine x, this becomes 1. That becomes tangent. I just wrote it in the wrong order, Sam.
No, but okay, like if I divide both sides. Oh yeah, never mind. I get it.
I divide both sides by cosine,
I
excuse
thought you were
me.
subtracting.
Oh no. Okay. Tan inverse of 1. What is it? Oh guys, come on.
Cosine over sine.
Pi over 4 is one answer.
How do you know that?
Mark, how do you know?
45 degrees.
I'm doing the unit circle, yes! 100%. What, is there another answer?
Pi over 2.
No.
2 pi over 3.
What?
7
5 pi over 4, that's the other answer.
Isn't it
All silly turtles crawl. Where is sine and cosine have the same sign? Quadrant 1, quadrant 3. So our answers for tangent equal to 1 can only be a positive value in quadrants 1, quadrants 3. So 45 degrees, x and y are the same coordinate, pi over 2, or root 2 over 2. That's 45 degrees in quadrant 1, or pi over 4. And then 45 degrees below the horizontal in quadrant 3 is negative root 2 over 2, comma, negative root 2 over 2, or 225 degrees, or 5 pi over 4. And really, what do we have to have after this still? And everything coterminal to those answers, right? So that's plus 2 pi k, where k is just some integer. For all integers k. So far, so good? All right. We need to check these, though. Because if they give us a 0 denominator, we have to throw them out. Will they give us a 0 denominator? No. I get root 2 over 2 plus root 2 over 2. That ain't 0. And negative root 2 over 2 plus negative root 2 over 2 ain't 0. So we're good. Sit down.
Can I use the bathroom?
Sure. How did that feel? Other than all the trick stuff, you're like, oh my god, I still need to remember this.
Yeah.
I'm sure you did equivalent solving of trig functions or trigonometric equations last year. You just kind of forgot. Which is okay to be rusty. It was a lot of memorizing. I don't memorize, I just kind of figure it out. I know what one quadrant looks like and I can just figure it out for any other quadrant. Rather than trying to memorize the whole thing. I don't know. All right. It says an object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and released at time 0. Its position at time t is given by s equals 4 cosine t. Find the velocity and acceleration at time t and use them to analyze the motion of the object. So what's the relationship between velocity and position?
What was it?
What's the relationship between velocity and position? Velocity is the derivative of position. What's the derivative of 4 cosine t?
Sine.
Negative.
Sine of t.
Negative 4 sine t.
Isn't the derivative of 4 0?
4 is a constant.
Yeah, so it would be 0.
So you can think about it as 4 times the derivative of cosine, right?
Oh.
But if you wanted to do a product rule, then it would be cosine t plus cosine t times the derivative of 4. And that drops out.
So we're not taking the derivative.
I mean, if you want to think about it as a product rule, you
That
can.
one we are not.
Yes.
Okay.
One part of the product rule you do and the other part you don't. But
Got it.
constants you can just pull in front of the derivative. You can just ignore them and put them back. It's okay? Okay. All right. What's the relationship between acceleration and velocity?
It's the derivative of velocity.
Mm-hmm. Which makes it the second derivative of position, right? Okay, what's the derivative of negative 4 sine t? Negative 4 cosine t. The derivative of sine is positive cosine. So I have negative 4 times positive cosine. You good? So that's velocity and acceleration at time t. And we want to use this then to analyze the motion of the object. So I'm just going to pick a couple of values for t. And we're going to going to use that then to analyze what's going on. Okay? All right. 4 times cosine 0 is 4 times 1, or 4. Okay. Negative 4 times sine 0 is 0. Negative 4 times cosine 0 is negative 4. Everybody happy? Okay, let's think about what this means. So we pulled the spring down, we're holding it at position 4. If we're holding it at position 4, the velocity is 0, because we're holding on to it. The acceleration is negative 4, which means it's being pulled back in this direction, opposite the way it was pulled from, because what is the spring going to want to do? Return back to its unstretched position, right? Does everybody feel good about that? Makes sense to you physically what's going on? Okay, let's do this now for pi over 4. 4 cosine pi over 4 is 4 root 2 over 2, or just 2 root 2? Because cosine pi over 4 is root 2 over 2, and then times 4 and reduced. Negative 4 times sine of pi over 4. Negative 2 root 2. And then negative 4 cosine pi over 4. Negative 4 cosine pi over 4. Negative 2 root 2. So what is this saying? So our object was stretched to here. It's moved up a little bit. In moving up, the velocity has gone in this direction, right? Because the velocity has a direction, so it's moving back towards, like, the origin, right? It's moved up in the orientation of our description. The acceleration now has decreased. It was negative 4, now it's negative 2. It's moving, it's like slowing down, because as your spring unstretches, is the pull more or less? Less. But it's increased the speed, right? So notice that when we talk about speed, what you're looking at for is the velocity and the acceleration in the same direction. So we're moving up and being pulled up, so that means we're speeding up. Is everybody okay with that? If the sign of velocity and acceleration match, like we're speeding up. If they're opposite, it's being slowed down. So eventually, once this thing passes, what's that?
Yeah.
You know from physics, right?
This Packlet is like this slowing down, speeding up, speeding up.
Yeah, good. So you should be pros when I ask you about this on the test, right? Okay. If we do the same thing with pi over 2, cosine, or 4 cosine pi over 2 is 0. Velocity, negative 4 sine pi over 2 is negative 4. And then negative 4 cosine pi over 2 is 0. So we've returned to the origin. At this point, we're going as fast as we're ever going to be, but there's no more acceleration because now the spring is completely unstretched, right? We'd expect then the thing to keep going up and kind of keep bobbing up and down, right? But that's when we talk about analyze the motion of the object, that's kind of what we're talking about. Do you guys feel okay with how I did this? We just calculate for a given time the position, velocity, and acceleration, kind of look at what's going on, whether it's speeding up or slowing down or whatever. Here we'd say it's like, is it speeding up or slowing down at pi over 2? Neither, right? What's the acceleration? 0. So it's like reached its max speed. It's now going to change from speeding up to slowing down. Does that feel okay? let's find the 27th derivative of cosine. Mr. Kulik, you gotta be just kidding with me right now. We're not doing 27th derivative of cosine. What are you thinking? You're right. What do you suppose that I'm gonna do here?
Plug 27.
Is it just gonna flip in between like sine and negative, like cosine or something like that?
I'm gonna look for a loop. That's exactly what I'm gonna do. I'm gonna just keep doing derivatives until I get back to the start, and then kind of figure out where to go from there. Everybody's okay? So the first derivative, what's the derivative of cosine?
Negative sine.
Negative sine. Second derivative, what's the derivative of negative sine?
Negative cosine.
Negative cosine. Third derivative, that's going to be positive sine, very good. And the fourth derivative is cosine. Stop. We're back to where we started. We formed a loop. So those are the four outcomes that we have here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27.
Sine of X. That's cool.
Right? Yeah. So if you're asked to find like a high number derivative, there's going to be some kind of loop or pattern or something going on. Nobody's going to expect you to actually do 27 derivatives. Like, that was really gross sounding. Gross. Sorry about that. But that's the idea. Everybody's okay?
Yes.
So this little thing that we did is called modular arithmetic, where you make like a clock and you just kind of count around the clock. There's a lot of important mathematics based on this kind of modular arithmetic. In particular, a lot of the cryptography, like the security that's built into like your digital communication, is built on this kind of mathematics. So next time you're sending a text message or an email and you're hoping that nobody can read it as you're sending it across a public network, the encryption that keeps it secure possibly is built around this kind of modular arithmetic. There's another kind that's built around like a transformation along an elliptical curve is the other common type of encryption. This is what you get to learn when you become a math doctor. I'm going to skip these two problems because frankly I don't care about using those limits. That's where we're at. So should you do this homework? Yes. Should you worry about it before the test too? No. You can sit on this and like wait until you're done with test 2 before starting this. Okay? Mr. Bullock will be lenient about due dates with, we take test 2 on like Thursday or something. I'm not going to expect this done on Sunday or anything like that.
Yeah, sorry.
That's okay. It's okay. I appreciate that you're like, you've got something in your craw and you want it.
No, I'm sorry.
I want to talk a bit about the test format here. So I'm looking at the test 2 tab on OneNote. Test 2, well, the due date, that's wrong now, right? Don't worry about the date that I have on there. 2 parts. Part 1 is the no calculator part. 10 multiple choice questions. 1 multiple part free response question. That's part 1. Part 2, 8 problems. Expect some of them to be derivative problems. Some of them will be just like take the derivative of this. Some of them will be Mr. Kulik originals that are just like, here's a kind of a conceptual-ish problem that's built around definitions of stuff. And then one multiple part free response question. That's the test. Okay? So topics that I have listed here is things that you should be able to do. Calculate average rate of change of a function, where that function is given as a graph, as an equation, as a table, as a piecewise. When I say average rate of change, really what we're talking about is slope. Excellent. Calculate or estimate instantaneous rates of change for a function where it's given as a graph, as an equation, as a table, as a piecewise. Talk about instantaneous rate of change, we're talking about derivative, right? Slope of a tangent line, equivalent statement. You should be familiar with the limit definition of a derivative and be able to use that to evaluate the limit in its form by taking the derivative. I'll give you an example of what I mean in a minute by that. I will not require you to use the limit definition of a derivative to find the derivative. Okay? So what I'm talking about here is if you see something like this, you should be able to use the limit definition of a derivative to evaluate this limit. What do you see when you look at this? You should see just take the derivative of x squared minus 5x plus 4. Because that's something you can do in your head, right? What's that derivative? Right? Ideally what you see here is this is like do you see it? That's how you should be able to use the limit definition of a derivative for the test. Is if you see a limit like that, you know all we're talking about is take the derivative. Everybody feel good? Be familiar with the different vocabulary or notation used to ask for a derivative. You know, like derivative, slope of a tangent line, instantaneous rate of change, etc. Or f prime of x, y prime, dy dx, ddx of some f of x. These are all just mean take the derivative. Be able to tell where a function is not differentiable and justified. So whether that function is given to you as a graph, as an equation, as a piecewise function, where are the places where a function is not differentiable?
It's purple and vertical, and when it's like a corner.
Vertical tangents, corners. There's two more. Discontinuity. Yep.
Infinity.
Not infinity, but a hard start, right? Like if it's like the square root function, it's not differentiable at the start of the graph. If it's like a closed, well, corner we already said, but this is just like a closed starting or ending spot. If the function is defined over a closed interval or partially closed interval, like the square root function. Be able to apply the derivative shortcuts to find the derivative or the definite derivative, whether that's for graph, a function as a graph, as a table, as an equation, as a piecewise, and then know and use the derivative relationship between position, velocity, and acceleration to answer questions. Everybody's okay here? Two topics from test 1 that should still be things that you can do. Definition of continuity. Why would that be important?
Because it's not differentiable if it's not
Perfect, because the function is not differentiable if it's not continuous there, right? Differentiability implies continuity, right? Have to have continuity to have differentiability. The reverse, but continuity is not guaranteed differentiability, right? Your canonical example is the corner, right? The second thing from test 1 that you should still be able to do, intermediate value theorem. The piece that you're going to see that, what do you need to have in order to use the intermediate value theorem? What? Continuity. Guess what you're going to use to get your continuity? Differentiability. If you're given a differentiable function, that guarantees continuity and now opens the door to use the IVT. Okay, so it's just another, we can now start layering these ideas on top of each other. No.
So would it be given to us then that it is differentiable since we don't know?
Right. So if you're given you might say the function f of x is differentiable over its domain. Selected values of f of x are given in the table below. Show that f of x, there's a solution, at least one solution to f of x equals 7.
Would we just be able to say, because I know this function is differentiable, I know it must also be continuous?
Yes. A sentence is perfect for that. Yes, 100%. Does everybody feel okay? So that's the test in a nutshell. Remember, we'll have a class day when we come back before the test, so you don't have to worry about coming and bothering me over break if you see something that you're I don't know what to do with this, or I'm not sure. You can still bother me over break, do that if you need to. It's not bothering me, it's part of my job, I'm used to it. But you'll have time in class also. Everybody cool? Okay, how do you feel? We got a little work to do probably. You feel okay, I know what I need to do. I know I can't do it right now, but I should have a pretty decent picture of what I need to get sharpened up on. Yeah? Again, on the OneNote, I have selected my EP questions covering content from test 2. I think that's a good place to study for the multiple choices. The answers are also there.
Good afternoon, Notre Dame Prep. Let's end today in prayer. In the name of the Father, the Son, and the Holy Spirit. Dear God, help us to love others with open hearts and generous spirits. Teach us to see the good in each person and to speak words that build up, not tear down. May our voices bring hope, kindness, and truth. Let our actions reflect your mercy and our words reflect your love. Amen. In the name of the Father, Son, and the Holy Spirit. Teachers may dismiss when you're ready.
I'd also say again, for studying purposes, I have a couple of FRQs, pre-response questions from the AP, also in here on My Notre Dame, on OneNote, also with answer keys attached to them.
Thank you.
So take a look at that stuff too as you're studying, whether it's this week or in the coming weeks. My advice is to start early and do a little bit, rather than try to do a big cram at the end. Okay. I'm done talking now. I can tell you guys are either